A very good morning to one and all. Myself, J. Anusha, working as lecturer in physics at SS Government Polytechnic, Zahirabad. I am dealing with the subject applied physics. So that is for first year, second sem students. And the subject code for applied physics is 18 common 203F. And the topic what we are going to discuss in today's session is electricity and measuring instruments. And from this topic, for today's session, we'll discuss about electricity. Now, as you have seen in the first slide, that is our main chapter, the fifth chapter from our syllabus, electricity and measuring instruments. So we'll see the first part of this chapter, that is electricity. In today's session, we are going to discuss about introduction to electricity. Now, I am working under Department of Technical Education, Telangana. Now, let us move on to our class. The main objective of today's session, today's class is, on completion of this period, you'll be able to understand what is electricity, that is the introduction to electricity. And while learning introduction to electricity, we'll learn about definition of electric current and a very important law, Ohm's law, and its explanation. So what is electricity? See, electricity is a form of energy which is involving the flow of electrons. Now, before discussing about the electrons, the matter which is present around us is made up of atoms. Now, these atoms contain positive charged particles which are called protons and neutrons which are at center of the atom, and the center of the atom which is called as nucleus, and negative charged particles which are revolving around this nucleus are called electrons. Now, the atom contains equal number of positive charged particles and negative charged particles. The force between these positive and negative charged particles is balanced. That is, an atom is electrically neutral in its normal state. Next, when balancing force between positive and negative charges is upset by application of outside force, atom may gain or it may lose electrons. Now, thus gaining or losing electrons leads to movement of electrons, that is negative charged particles. The movement of flow of electron from one point to another point in a conductor is known as electric current, or simply it is known as electricity. So how this electricity is coming, or else what is the reason behind this electric current? That is because of some external force applied on the nucleus. The balancing force between positive and negative charged particles which are present in the which are revolving around the nucleus, it leads to flow of electrons from one point to another point in a conductor. Now, what is Ohm's law? Now, it was given by Ohm. Now, according to Ohm's law, it gives the strength of flow of current in a conductor when potential difference exists between the ends of conductor. Now, when we can see this Ohm's law? When there is potential difference across the ends of conductor in which there is flow of current. Now let us learn what is statement of Ohm's law. A very important statement. At constant temperature, the current passing through a conductor is proportional to the potential difference between its ends. Now if we consider a conductor which is having both the ends, at both the ends if there is potential difference, then the current which is passing through that is proportional to this potential difference at constant temperature. Now let us see how we can explain this Ohm's law. Here you can see a metal conductor which is having two ends. At the two ends you can see positive charge and negative charge. What it means? There is potential difference at the ends of conductor. Now here A and B are charged bodies. A is positively charged and B is negatively charged. These two are connected using a metal conductor. Now this A is a body having potential difference, having potential, positive potential, that is VA, and B is a body having negative potential VB. Now these A and B bodies are connected by a conductor. Now you can see in the picture we are connecting. Let me show you. This is the body A and this is the body B. Now these two bodies are connected with a conductor. Now what it means? These two are ends of conductor. At the ends of conductor, at one end we are having positive potential and at one end we are having negative potential. So there is potential difference across the conductor. Let the potential difference between the ends of conductor is VA minus VB, which is equals to V. Now the current which is flowing through this conductor is I. Then according to Ohm's law, the current is directly proportional to potential difference. So I is directly proportional to V. Now if we take it out proportionality, we'll get one constant. So that is R. So V by I is equals to R, where this R is electrical resistance. So finally, Ohm's law is expressed in terms of an equation that is V equals to I into R. Now here you can see we can represent this Ohm's law by using a triangle. Now you can see in a triangle we divided it into three parts. They are represented by potential difference, electric current and resistance. Potential difference is V, electric current is I and resistance is R. Now in the first triangle you can see we are expressing potential difference as V is equals to I into R. And in the second triangle you can see we are representing or we are expressing the equation for electric current I. You can see I is equals to what are remaining? V and R. Now you can see in the picture V and R related with a division mark. You can take it as division, and this is V by R. That is what we have written here. I is equals to V by R. And similarly in the third triangle you can see we are expressing R in terms of V and I. So where R is equals to V by I. Very, very, very useful triangle which is giving expressions for potential difference, electric current and resistance. Once again, remember these three formulas. Potential difference is expressed as V equals to I into R, and I is equals to V by R, and R is equals to V by I. Now what is unit of resistance? The unit of resistance is ohm. The symbol for resistance is ohm. Now what is ohm? The ohm is a resistance of a conductor when 1 volt potential difference is maintained and a current of 1 ampere flows through the conductor at constant temperature. Now what is the effect of temperature on resistance? In metallic conductors, the resistance increase on temperature increases. In semiconductors, the resistance decreases on temperature increase. Later on, in other sessions, we are going to discuss about this effect of temperature on resistance in detailed form. So you just remember, as the temperature increases for metallic conductors, resistance also increases, and for semiconductors the resistance decreases. Now what are limitations of Ohm's law? It is applicable to metallic conductors. The conductors that obey Ohm's law are called ohmic, and which does not obey, they are non-ohmic. So semiconductors and vacuum tubes are known as non-ohmic conductors. This is also we are going to see in next sessions what are ohmic and non-ohmic conductors. Now what we learned in this session, this is our summary. We have discussed the following. We discussed about electricity and we discussed about Ohm's law. The flow of electrons is simply electricity, and the relation between electric current and potential difference is expressed by Ohm's law. Now when we are discussing about Ohm's law, we got a constant, that is resistance. That resistance is expressed in terms of ohm. So let us see how much we learned in this session. Electric current is due to flow of atoms, flow of protons, flow of electrons, none of the above. Obviously it is because of flow of electrons, which are negatively charged particles. The direction of flow of electric current is in the direction of flow of electrons, opposite direction to the direction of flow of electrons, negative potentials to positive potentials, none of the above. So this is opposite to the direction of flow of electrons. Now Ohm's law gives the relation V equals to Ri, R by I equals to V, Vi is equals to R, or none of the above. That is V equals to R into I. Now resistance is expressed in volt, ampere, ohm, or none of the above. Now as this resistance is defined after learning about Ohm's law, the resistance is expressed in terms of ohm. Now here are some frequently asked questions. You may get a question, what is electricity? And state and explain Ohm's law. Thank you so much. With this, I'm concluding this session. I hope you understood about electricity and Ohm's law. Once again, thank you so much for listening the class carefully. Let us understand the concept of electricity or introduction to electricity by watching this small video.
Vital to our civilization. Electricity is vital to our civilization. So what is electricity and how does it work? To explain electricity, we need to zoom past the molecular and into the atomic level. Atoms are the smallest things we can kind of see, but not with the naked eye. Only with a scanning, tunneling microscope can we get a glimpse of somewhat fuzzy spheres. To really understand electricity, we must go even further and look inside an atom. This is where it gets complicated, because the inside of an atom cannot be seen, at least not at the time of writing. So we will use this representation of the inside of an atom. This is called the Bohr model. Keep in mind that it is not to scale and only two-dimensional. This model is also known as the planetary model, modeling the parts of an atom as planets orbiting a sun or moons around a planet. While actually these orbiting moons are not at any one place at any one time at all, but exist more as regions or clouds around the core. However inaccurate the Bohr model might be, it will do for our explanation of electricity. Atoms consist of protons and neutrons. These form the nucleus of the atom. Orbiting the nucleus are the electrons. It's these electrons that are responsible for electricity, hence the name. Think of these orbits more as shells surrounding the nucleus. What type of atom, which element it is defined by the number of protons in the nucleus at the center. Atoms of one element all have the same number of protons, but can have different numbers of neutrons and electrons. It's this variable number of electrons that is important to our understanding. Electrons, which are far lighter than the protons in the nucleus, can relatively easily move. And this is important because the movement of electrons is what forms an electric current. The atom's protons account for the positive charge of the nucleus, and the electrons for the negative charge. In a stable resting, or rather neutral electrical condition, these charges balance each other out within the atom. This gives the atom a net electric charge of 0. For each positive proton, you will find one negative electron. In this state, the atom is at its lowest possible energy level, which we call the ground state of the atom. However, we can change the atom's charge or energy level by causing it to gain or lose electrons. When the atom has fewer electrons than protons, it becomes positively charged. But when the atom has more electrons than protons, the net charge swings back the other way and it becomes negatively charged. More electrons than protons mean the atom is negatively charged. Fewer electrons than protons mean it is positively charged. Losing or gaining electrons changes the atom's electric charge. The remainder of this video we will color code the atoms as follows. A positive charge or absence of electrons is represented with red. A negative charge, a surplus of electrons, is represented with blue. Neutral charge, or a balance between electrons and protons, is represented by a blend of red and blue, purple. So when in a ground state or uncharged, it looks like this, and it's called an atom. When charged, negatively or positively, it looks like these. Instead of atoms, when there is a charge, these are called a negative or positive ion. Each shell of an atom can hold a maximum number of electrons. The inner shell can hold 2 electrons, the second can hold 8, the third 18, and there are elements with all 7 known shells. Shells are populated with electrons from the inside out, meaning that added electrons always go for the innermost shell possible with a spot left. The number of electrons on the outermost shell determines the reactivity of the atom. This shell is called the valence shell, and its electrons are called valence electrons. When the outermost shell is full, the atom is generally stable and least reactive. You may be familiar with the term and effect of static electricity. When you, for instance, shuffle your feet over a nice soft carpet, you build up a positive charge, because negatively charged electrons are being lost to the carpet. Carpets are often made from a material with the properties of an insulator. Insulators do not easily give up electrons but can get a local charge when electrons from a conductor are rubbed off on them. An insulator's valence shell is already quite full of electrons. These electrons will just sit there until something else takes them away. However, your body is a conductor. Conductors have loosely bound valence electrons which are easily transferred or lost, in this case from your body to the area of the carpet where you're shuffling. Instead of you and the carpet having a neutral charge, a charge imbalance is being created between you and the carpet. Now, when you touch a metal object, for instance a doorknob, you get zapped. The doorknob may be neutrally charged, it is metal, and metals too are conductors with loosely bound electrons on the outer shells of their atoms. These electrons immediately move to your body to restore the charge imbalance, giving you a jolt. Nature always seeks a neutral charge equilibrium, a net charge of zero. Materials with high electron mobility are called conductors. Materials with low electron mobility are called insulators. A commonplace object where you can see an insulator and conductor working together is in a simple wire. This electrical wire has a copper core and a plastic shell. Copper atoms have a very loosely bound electron on the outside, as seen here again using the Bohr model. This makes copper a perfect conductor, whereas the plastic is an insulator. The millions, if not billions, of copper atoms in this piece of wire easily exchange electrons, allowing us to make an electrical circuit with it. Think of an electrical circuit as a path that connects 2 points with a possible charge imbalance, usually connecting a negatively charged point to a positively charged point. Like marbles in a tube, moving from a high place full of marbles to a low place lacking marbles. Imagine these marbles all along the circuit, each marble being an electron. These marbles originate from a power source, for instance a battery. And we'll explain how batteries work exactly in a future video. Electrons move from the negative to the positive, as we've established earlier. The battery pushes out electrons from one end and attracts them from the other. As one is pulled in, one is pushed out. Despite the electrons moving relatively slowly, this effect causes the energy to be transferred almost instantaneously. To create such a flow of electrons, we must provide them a path with a conductor, such as the copper within our wire. If this path is blocked by an insulator, such as plastic, rubber, or air in the case of a cut wire, the electrons cannot continue to flow, stopping the electric current. The key to the flow of electricity is making a continuous electrical circuit, connecting a wire between a source of electrons and an attractor of electrons. All electrical devices are powered this way. That is why your battery has 2 poles, a source and an attractor, a negative and a positive. This is also why your electrical plug has at least 2 tongs, one for incoming electrons, one for outgoing. You see, electrons are not spent, they do not cease existing. They are mere carriers of charge and can only be useful on their way to their destination. Take note that connecting 2 poles of a power source directly can actually be very dangerous. This is what's called a short circuit, because there is nothing between the source and the destination of electrons to power, such as a lamp or television. This means that the electron flow will not encounter any resistance. The release of energy when short-circuiting is therefore instant, often paired with the involved wire heating dangerously. This is why buildings and some devices have fuses. These automatically cut the current flow when the current becomes too high, preventing damage or worse. In the next videos on electricity, we'll learn more about generating power, resistance, voltage, amperes.
Is Ohm's law. We know there are three main terms used to describe the electricity. Voltage denoted by V, resistance denoted by R, and current denoted by I. This is George Ohm. He is the one who stated the relationship among voltage, resistance and current. He saw that at a constant temperature, the electrical current flowing through a fixed linear resistance is directly proportional to the voltage applied across it. If voltage goes up, then the current also goes up at the same factor. If the voltage goes down, then the current goes down by the same factor. And if we fix the voltage at a constant value and make the resistance a variable, if resistance goes up, then the current goes down. If the resistance goes down, then the current goes up. That means current is inversely proportional to the resistance. This relationship between voltage, current and resistance forms the basis of Ohm's law. Current equal to voltage divided by resistance. Let's replace the terms by the notations. I equal to V divided by R. By knowing any two values of the voltage, current or resistance quantities, we can use Ohm's law to find the third missing value. To find the current, we need to know voltage and resistance. To find the resistance, we need to know voltage and current. To find the voltage, we need to know current and resistance. It is sometimes easier to remember the Ohm's law relationship by using pictures. Here the three quantities of V, I and R have been superimposed into a triangle. We call this as Ohm's law triangle. Giving voltage at the top with current and resistance below. This arrangement represents the actual position of each quantity within the Ohm's law formula. Transposing the standard Ohm's law equation above will give us the following combination of the same equation. V equal to I times R, I equal to V divided by R, and R equal to V divided by I. Let's go for an example. This is a simple circuit that only consists of a power source and a resistor. We can measure the voltage across the resistor by adding a voltmeter parallel to the resistor, and also we can measure the current by adding an ammeter series to the resistor. By knowing V and I, we can calculate the resistance of the resistor using the Ohm's law.